everyone, in this video we're going to talk about how to determine whether a molecule is polar or nonpolar and what type of intermolecular force or IMF it has. So let's go ahead and get started. So what does it mean to be a polar molecule? If a molecule is polar, that means one side is positively charged and the other side is negatively charged. It's kind of like a battery where you have one positive end and one negative end. So polar bonds are much stronger than nonpolar bonds, kind of like there's always one stronger side in a tug-of-war game and there's always one weaker side. If a substance is polar, it can easily dissolve in water because water is polar itself, okay? So in order to figure out if something is polar, there's an easy flow chart that you can follow. The first question you want to ask yourself, are ions present? That simply means, is it ionic? If it is ionic, you can stop right there. Remember, an ionic compound is made up of a metal and a nonmetal. So if it has a metal, you're done. If it's a covalent compound, you have to take the journey down the left-hand side. Are there more than two atoms present? So does that mean if there's three or more, you're going to go this way. If there's only two, then you're going to come down. So 2 would be H2, Cl2, or OH, or NaCl. Those all have two different compounds. If there's three or more, you want to ask yourself, is the Lewis structure symmetrical? If it's symmetrical, then it's going to be nonpolar because it will have an equal pull in each direction from the left, the right, the top, and the bottom. If it's not symmetrical, then it's going to be polar because one side is going to have a greater pull than the other. Now, if we go back over here, if you have two of the same element, it's going to be nonpolar because they're each going to pull with the same strength on both sides. If they are not the same element, one element always has a greater pull than the other one. So let's do some practice problems together. You might want to keep up that flow chart just as an FYI as we go through some of these. Okay, so here we go. The first one we're going to do is CH4. So we want to ask ourselves, are ions present? Is it ionic? The answer is no, because they're all nonmetals. Are there more than two atoms present? The answer is yes. There's 5. 4 plus 1 is 5. And then is the Lewis structure symmetrical? It is symmetrical because the left, the right, the top, the bottom are all the same, so it's going to be nonpolar. Okay? Let's try another. H2O. We're going to ask ourselves, is it ionic? The answer is no, so we go this way. Are there more than two atoms present? The answer is yes. There's 3. 2 plus 1 is 3. We're going to ask ourselves, is the Lewis structure symmetrical? The answer is no, because the left and the right are the same, but then we have the Lewis or the lone pairs at the top, but not at the bottom, so it's going to be polar. Okay, let's try another. Our next one is N2. Once again, we ask ourselves, is it ionic? The answer is no, because there's no metals present. Are there more than two atoms? The answer is no, because there's only 2. Are both atoms the same? The answer is yes. So it has to be nonpolar. Okay, so remember, since it's nonpolar, each N is going to have the same pull on the compound. Okay, let's try another one. We have HF. We're going to ask ourselves, is it ionic? The answer is no, because there's no metals. Are there more than two atoms? The answer is still no, because there's only 2, 1 hydrogen, 1 fluorine. Are both atoms the same element? The answer is no, so that means it's going to be polar. One element is going to have a much stronger pull than the other one. There's always someone stronger than the other. Okay? Let's see. All right, so hopefully you understand how to do polar and nonpolar now. Let's add intermolecular forces to this. So what is an intermolecular force, or IMF? An intermolecular force is the force that exists between molecules. So what is holding two different molecules or compounds together? This is going to determine the physical property of the molecule. So the boiling point, the melting point, is it going to boil very easily? Is it going to melt very easy? Kind of like wax melts very easy, but steel or gold does not melt very easily. The density of the compound and enthalpies like fusion and vaporization. So these IMFs all help us to determine those different things. There's 3 different kinds. The first kind is London dispersion. London dispersion is the weakest of all of the forces. It's going to exist between an ionic and a covalent molecule. And it's typically because they're breaking bonds that require very low energy. Okay? So it's going to be a very low energy. The second type is dipole dipole. So when it's dipole dipole, you're going to have a partial positive charge of one compound, and it's going to interact with a negative compound of the other. So here we have the positive and the negative interacting, so that's our dipole dipole. The third type is a hydrogen bond. These are very strong bonds, and they only occur when hydrogen is bonded to fluorine, oxygen, or nitrogen. The hydrogen bond has to be touching one of them. There is a lot of energy that is needed to break these bonds apart, and they are responsible for holding the DNA and RNA together in biology. And those are extremely powerful strands, so we know how strong these hydrogen bonds must be. Okay? So we have a flow chart for this as well. So you want to ask yourself, is the molecule polar? If it is polar, you're going to say, does the molecule have any of these bonds, HN, HO, or HF? If it does, you know it has to be a hydrogen bond. If not, it's dipole dipole. If the molecule was not polar, then its only option is London dispersion. Okay? So let's go ahead and do some practice problems. I'm going to bring up the flow chart. Okay? Here we go. So first we're going to have to figure out if it's polar or not, and then we can do the IMF. Okay? So here we said CH4. We knew that CH4 was nonpolar because the Lewis structure was symmetrical. So since it was nonpolar, we can go down here. Is the molecule polar? The answer was no, so it has to be London dispersion. If you don't remember how we got polar and nonpolar, you're going to want to review the beginning of the video. Okay? The next one was water. We knew that water was polar. Okay, so is the molecule polar? The answer is yes. Does the molecule have any of the following bonds, HN, HO, or HF? We can see that hydrogen is bonded to oxygen. Now, since it is bonded to oxygen, we know it's going to be a hydrogen bond. There we go. All right, our next one was N2. We knew that N2 was nonpolar. Since it's nonpolar, the only option is London dispersion. Okay, there we go. And we're going to do one more together. Our last one is HF. We knew that HF was polar, so we travel to the right. Does the molecule have any of the bonds, HN, HO, or HF? H is bonded to F, so we travel down, and we know it has to be a hydrogen bond. Okay? So just keep in mind that you have to do polar and nonpolar before you can do your IMF force. If you have any questions, please let me know. Thank you.